We are going to see the seventh problem in radius of curvature. The tangent at the point P and Q on the cycloid. P and Q on the cycloid x equal to a into theta minus sin theta and y equal to a into 1 minus cos theta are right angles if rho 1 and rho 2 are the radius of curvature. Prove that rho 1 square plus rho 2 square equal to 16a square. Solution: x equal to a into theta minus sin theta. X is in terms of theta, so we differentiate with respect to theta. Dx by d theta equal to a into differentiation of theta with respect to theta is 1. Differentiation of sin theta is cos theta. So we get a into 1 minus cos theta. Y equal to a into 1 minus cos theta. Differentiation of y with respect to theta is dy by d theta equal to a into minus of differentiation of cos theta is minus sin theta. So minus into minus we get sin theta plus sin theta. y1 we can denote it by first differentiation dy by dx. Dy by dx can be written as dy by d theta by dx by d theta. y1 equal to dy by dx dy by dx equal to, instead of dy by d theta we can write a sin theta. Instead of dx by d theta we can write a into 1 minus cos theta. A into 1 minus cos theta. A get cancel. Y1 equal to half angle formula sin theta. The formula for sin theta is 2 sin theta by 2 cos theta by 2. 1 minus formula for 1 minus cos theta is 2 sin square theta by 2. 2 get cancelled, sin theta by 2 get cancelled. Y1 equal to cos theta by sin theta, we get cot theta by 2. Y2 equal to d square y by dx square. D square y by dx square can be written as d by dx of dy by dx. So y2 equal to multiplying and in dividing by d theta we get d by d theta of, instead of dy by dx we can write cot theta by 2. The result we get cot theta by 2 into d theta by dx. Differentiation of cot theta by 2 is minus cosecant square theta by 2. The angle differentiation of angle theta by 2 is 1 by 2 into 1 by 2. By dx by dt d theta. Instead of dx by d theta we can write a into 1 minus cos theta minus cosecant square theta 2 into 2a 2 into 2a 1 minus cos theta formula is 2 sin square theta by 2. So we get cosecant theta is 1 by sin theta. The formula for cosecant theta is 1 by sin theta. So we get y2 equal to minus 1 by 4a into sin raised to 4 theta by 2. Sin raised to 4 theta by 2. The numerator we have cosecant square theta by 2. It will the formula is 1 by sin square theta by 2. So sin square theta by 2 into sin square theta by 2 we get 4a sin raised to 4 theta by 2. Radius of curvature rho equal to 1 plus y1 square the whole raised to 3 by 2 by y2. 1 plus minus of 1 plus cot for y1 instead of y1 we get we can write a cot square theta by 2 the whole raised to 3 by 2, where the formula for the result for y2 is minus 1 by 4a into sin raised to 4 theta by 2 minus 1 by 4a sin raised to 4 theta by 2. Equal to minus 1 plus cot square theta the whole raised to 3 by 2. We take the reciprocal of 1 by 4a sin raised to 4 by theta. So we get 4a sin raised to 4 theta by 2. And the formula for 1 plus cot square theta is cosecant square theta. So we get minus cosecant square theta by 2, 4a sin raised to 4 theta by 2. The power get cancelled, 2 and 2 get cancelled. So we get rho equal to minus cosecant cube theta by 2 4a sin raised to 4 theta by 2 equal to minus 4a sin 4 theta by 2 by sin cube theta by 2. Sin cube theta and if sin power 4 theta get cancelled, we get rho equal to minus 4a sin theta by 2 at p. At p we denote rho by rho 1. At p we denote rho by rho 1. Rho 1 equal to minus 4a sin theta 1 by 2. At q we denote rho 2. Rho 2 equal to minus 4a sin theta 2 by 2. Squaring and adding. Rho 1 square plus rho 2 square equal to 16a square sin square theta 1 by 2 plus 16a square sin square theta by 2. We get in the two term the 16a square is constant, so we can take outside 16a square into sin square theta 1 by 2 plus sin square theta 2 by 2 rho 1 square plus rho 2 square equal to 16a square, hence proved. Radius of curvature in polar coordinates rho equal to r square plus r1 square the whole raised to 3 by 2 r square plus 2r1 square minus r2. The another formula for radius of curvature in polar coordinates. R1 equal to dr by d theta, R2 equal to d square r by d theta square. So radius of curvature in polar coordinates formula is rho equal to r square plus r1 square the whole raised to 3 by 2 by r square plus 2r1 square minus r2. R1 equal to dr by d theta, R2 equal to d square r by d theta square. Proof the formula the proof for the formula proof. Let us assume that the equation of the curve in polar coordinates be r equal to f theta. The figure we draw O as the origin, the slope p, the line we draw, the angle for slope is psi. From the origin we draw two lines. One angle is theta, another angle is phi. This line is we get the OP we denoted by R, ON we denoted by R plus theta, delta R. The curve we draw the curve, we denote the point as P. So now from the figure we can write a psi equal to theta plus phi. From the figure we can write a psi equal to theta plus phi. Differentiate with respect to theta, d psi by d theta equal to 1 plus d theta by d phi by d theta. Differentiate with respect to theta. So we get d psi by d theta equal to 1 plus d phi by d theta. And we know the result tan phi equal to, this is some result, tan phi equal to r by dr by d theta. Tan phi equal to r by dr by theta. Differentiating with respect to theta, differentiation of tan phi is secant square phi d phi by d theta equal to the differentiation u by v form. V into v, instead of v we write dr by d theta, differentiation of u dr by d theta minus r into differentiation of v d square r by d theta square by v square dr by d theta the whole square. So d phi by d theta equal to secant square phi we cross multiply 1 by secant square phi dr by d theta into dr by d theta, we get dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square. So equal to 1 by secant square phi formula is 1 plus tan square phi. Secant square phi formula is 1 plus tan square phi into dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square equal to 1 plus, instead of tan phi we can write the result r by dr by d theta, r by dr by d theta the whole square. So we get 1 plus r square by dr by d theta the whole square, dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square. By taking the LCM in the denominator, we get dr by d theta the whole square, dr by d theta the whole square plus r square into dr by d theta the whole square minus r into d square r by d theta square dr by d theta the whole square. Dr by d theta the whole square get cancelled. So we get d phi by d theta equal to dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square plus r square. We have the result, already we have the result, d psi by d theta equal to 1 plus d phi by d theta. 1 plus, instead of d phi by d theta we can write dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square plus r square. By taking the LCM we get dr by d theta the whole square plus r square plus dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square plus r square. So we get dr by d theta plus the whole square plus dr by d theta the whole square, we get 2 dr by d theta the whole square. So equal to r square plus 2 dr by d theta the whole square minus r into d square r by d theta square by dr by d theta the whole square plus r square. We know that the result, this is some result given, ds by d theta equal to r square plus dr by d theta the whole square the whole raised to 1 by 2. This is a result. So rho equal to ds by d phi. Ds by d phi can be written as ds by d theta into d theta by d psi. So ds by d theta, instead of ds by d theta we can write r square plus dr by d theta the whole square, the whole raised to 1 by 2. Instead of d theta by d psi we can write dr by d theta the whole square plus r square by r square plus 2r by 2 into dr by d theta the whole square minus r into d square r by d theta square. R square a power m and a power n, we can write a power m plus n. Using this formula, r square plus dr by d theta the whole square, the whole raised to 1 by 2 already we have the power. Also we have the another power 1. 1 by 2 plus 1 we get 3 by 2 by r square plus 2 dr by d theta the whole square minus r into d square r by d theta square. Hence rho equal to r square plus r1 square the whole raised to 3 by 2 by r square plus 2r1. First differentiation we denote by r1. So 2r1 square minus r2. R2 is the second differentiation where r1 equal to dr by d theta, r2 equal to d square r by d theta square.